All right. Welcome, everybody. Hello, NDC. How are you? It's amazing to see live people, really. So, today we are going to talk about performance testing, or how to break it and make it better, right? In this session, I'm going to, that's my promise, at the end of the session, I will ask you, did I get to the point of teaching you why performance testing is important, why should we use K6 as a proper alternative, and also teach you how to use K6 until you can build a proper, seemingly real-life end-to-end performance test. So that's my promise to you. At the end of the sessions, you will get that. So take it as a bit of fun session and also a bit of a learning, which is meant to be fun. So, who I am? My name is José Luis Latorre. I'm Spanish, born in Barcelona, but working in Switzerland in Swiss life, living the Swiss life. My Twitter ID is GOSLAT. That's made from my first part of 3 letters of my name, JOS and LAT, and that's the same for GitHub. I've been awarded 9 times as a Microsoft MVP. Sadly, war got in the middle, but now I'm getting back to public speaking, so we'll see. And I'm a software architect at Swiss Life, also coding a lot, and a developer community lead, helping the developers to have fun while doing great work and getting better at what they do. Also, in my private life, I'm also public speaking and leading the .NET user group at Zurich, which is quite fun. Been doing that for a while. And today, I will tell you a bit why you should listen to me. By luck, or bad luck, I've been in several situations in my life that have driven me to be the troubleshooter. I don't know, how many of you have ever been into troubleshooting, investigating a problem that nobody knows why that is happening? I've been there. Oh, quite a lot. So you know the pain, right? So I've been doing that for a lot of time until they got me, hey, Jose, they put me the hat of a troubleshooter to find the issues and to fix them, well, quite for a while. And yeah, I don't know if it's luck or not, but sometimes life puts you in very complicated situations. And what I'm going to show you is one of them that you may think initially it has nothing related to performance testing, but this is my bathroom. This is 1 week from now. What would have happened if it got me washing my teeth, for example? It wouldn't have been nice. Technicians came, and they saw in the upper right that this was caused by a leak. And they suddenly investigated a bit more. So they opened up. And so the pipes, which, if you think about that, if you think as an apartment, as a microservice, as a container or microservice, and the pipelines as a messaging pipeline, it sort of makes sense. There was a leak there that had been going for a while. The infrastructure here was severely damaged, and they had to reinforce it. So I was lucky not to be there. I was lucky nobody died. And that just happened 1 week ago. I think it was a perfect example. Later on, the technicians came and did this. This is a bit of duct taping, but you are familiar with that, right? And this is a pipeline, and it's not glue, so it's we can call it staging, right? So they did testing, not simple testing. They didn't drop one message to see if it works. They did it as it should be. They put and call all the buildings and say, hey, now open and flush whatever you're doing in there and see if it works. Sometimes it's the only way and the best way to determine if this system will work in real life. Later on, they put almost in production. This was sent to me like yesterday. So I hope it will be all right and not happen again. So these kind of situations have happened to me for a while, and I'm shaped a bit in performance testing, troubleshooting, analysis of code, mostly in .NET since 2004. So kind of the kind of person that I'm very stubborn. I have a friend, Michael Stab. He's German, but he tells me, hey, Jose, you are more German than any other German that I know, even me. And sorry, I'm Spanish, not German. So I'm that kind of stubborn. I get to one thing and I don't let it go until it's done. My girlfriend hates it. All right. So today we're going to see why you should do performance testing. Well, seeing the amount of people, you're already convinced that performance testing is important, right? But this session, I'll give you some points that you can convince your boss. If you tell, hey, I think we should do performance testing, he'll probably come back and say, sorry, we don't have budget. So I'll help you convince them. I'll tell you why I pick up K6, what are my reasons. I'll give you a hands-on introduction to K6, and I'll show you the template. You'll see that later. So first of all, why should you be testing at all? There's some people that don't see value in testing. They say it costs money, and it works, right? Basically, you can avoid human mistakes by fully automating things. And if you work in healthcare or in finance, it can be mandatory in some cases. As well as, well, it increases the quality, or you can ensure that the quality is there and that it will not break with. And you can identify defects regularly and will reduce flaws and avoid the new flaws are added when you change and refactor your code. So I think it's important. And everybody is doing with the pyramid. I don't know if you have worked with, what's the name? Performance test lead or test lead or test manager. They do the plan, and the plan is perfect. And the plan usually follows the pyramid, where you have a lot of tests in the unit tests, then you have a less integration component. Usually they don't do. And then some integration tests, and at the end, maybe if you're lucky, they will do end-to-end tests or UI tests. And that's everything, because as you go up, it costs money. And apart from that, usually you find nothing more, even in serious projects that are regulated in a health environment. It's very sad because here, there is a big problem. Anybody can see the problem here? Everything here is functional. You are mostly testing for one single user. But what if you have 100 users simultaneous or 100 services attacking your microservice or API? Well, thing changes, right? But, well, you know, Murphy lives. If you don't do that, things will happen. And performance tests are key to identify real-life issues. In fact, it's the only way. It's as close as reality as you can get, unless you want to let your users or customers to test your software, which usually is not a good idea. Happened before. Been there. One of the situations I told you, this one is one I live. Once upon a time, there was a system under development. I think it was 6 years. We were into it together with a colleague that was supposed to sit in front of me now, but you know, he was Group B, so not here, sadly. And Norman and me were on that project. Hi, Norman. And after 6 years, they decided to put the database under the full load it had to have in production after 6 years. And guess what happened? Murphy lives. And they discovered quite a several set of issues there. That took 1 year, or more than 1 year, for one architect and a team dedicated several months to mitigate it. But they have to delay that for 1 year. And the commercial losses, everything. Just the mitigation costed a bit more than $2 million. If that sounds like a lot of money, wait for the next. The Note 7 battery costed $70 million. Not bad, right? And well, apart from that, it's not only money. Some people kind of almost lose their legs, or somebody lose their legs. So it's, well, I think that's more serious than the money. I think nobody died, but there were serious injuries, and people will have to endure pain for lives. And you don't want your software to do that, right? And, well, if you test in production, I don't have to remind you that. You know it very well. Another example, anybody knows Knight? I don't know if it's Knight Investments. I think there was a session some days ago. It was mentioned by Dylan Beatty. I think you have seen Dylan Beatty everywhere these days. He's a fantastic speaker. And Knight had a problem. They deployed a release without testing that had a flag. I think the Power Pack was called. And that caused in like kind of every minute that the system was leaking some kind of orders that were not prepared, that this kind of flag was triggering. This trigger, I think it was $10 million per minute. So at the end, it was close to $500 million, 500 million. Wow. Well, still, nothing close to lose your life. And well, at the end, performance testing can avoid all of this. It's worth it. Ensures reliability. And your project success shows how brittle it is when you put the expected load in users or data. And verifies SLA. SLA is service level agreements that you're lucky if you have them. Otherwise, these tests, you can say, okay, my API, my web responds in 300 milliseconds. That's your SLA. Give it or take it. If you want it better, let us know. At least you turn the table around and you tell your manager, that's the SLA it covers. You want more? Give us money for more developers. That usually doesn't work. And we'll save money, a lot of money, because it reduces the risk. And if you detect them as close as you produce them, and you implement performance testing from day 0, well, you see that. There's a study that showed that as soon as you detect it, it's easier and cheaper to fix. In the case of an apartment or a building, if the problem is on the main infrastructure, well, it would take quite a few days. But if they detect it right away, it's just a swap. Go ahead. So, and more important, it saves us from stress. We all want to live happily and develop code that works. And we deploy, we go home. We know we don't have to be there the weekend, right? Because we have tested it properly. And as well, this is daring, but I truly believe your software can save lives. If you work in healthcare, can save people from a false positive or a false negative, which, I don't know if you suffer that, but some time ago, last year, my girlfriend had 2 false positives with a COVID test, and she was super healthy, and I was completely negative. So I asked for a retest because I was in the PCR, and I know they are not 90% perfect. And the people handling that, well, there's human mistakes. So we don't want that to happen, and testing is one way to solve it. Hope you are now convinced that performance testing is important. And now I'll tell you why you should try K6. How many of you have tried K6 or know what K6 is? Raise your hands. I know it a bit. 1, 2, 3. Yeah, not everybody. K6 is a company that started as a gaming company, and they wanted to do like an MMORPG, but they had some performance problems, and they implemented a performance test suite. And that turned out to be so good that they converted all their business into that. Really. They also had 2 alligators, and that's true. You can go to k6.io and watch it. It's a funny story. My decision points there were performance was pretty good. They have an open source version, and it's kept really, really, really well. It's based on code, so you don't depend on an UI to define your test. And you can integrate first this test into your pipeline in a CI/CD pipeline, Azure DevOps, for example. And it's really easy to do that. We will see how to do that later. It has many outputs and integrations, and if there is not the one you want, it is extensible. They have extensibility option that they did, I think, like 7 or 8 months ago. It's pretty open, and the community is vibrant. Talking about community, I was talking to Nicole. Nicole is a developer evangelist from K6, and also with Flor Dress. Maybe you know it. She was a developer evangelist at Microsoft that recently joined K6, and they told me, hey, why don't we do that? You make some questions to the audience, and if they respond properly, we will send 3 swag kits from K6. I think there's a T-shirt, a nice bag, some stickers. I think I got one here. Yep, K6. And if you want that, put attention. I'll make you questions, 3 questions. And the person that gets it right the first, well, you come later, tell me your name, I will write it down and your email, and I'll send that to Nicole and Flor, and they will get you a kit, a swag kit. All right. So, and they have a lot of more things. They are evolving the system like crazy. They were also acquired recently by Graphana, an observability platform, which is pretty cool, and they have a strong focus in open source. And yeah, and they recently announced that they opened like a performance test suite for attacking or doing tests against a UI, to HTML UI, kind of similar to other platforms I will not mention. But the good thing is it's highly performant because it does not depend on a UI that I know. I still have not really fully checked. It's also very modern. So it was designed, built about 5 years ago, and they are not stopping. The ones in red, before you ask, are the ones that depend on a UI. So they are UI-driven. So if the UI changes, the generated file that they use may change. So you may lose some format or functionality. So that's your own risk. It's really active. So it has a lot of commits, and they release really, really very frequently. And they have a very good performance too. RPS, before you ask, it's a request per second. So this is a bit old. And what I like is the ratio comparison of the one in orange is the memory usage. So it's quite good. It's not the best, though. But what I was looking is a good equilibrium between features, ease of use, that its code it can integrate with my Azure DevOps. And yeah, that means I put that in my project. I'll show you in a moment later. So, and that's why I pick up K6, and I think it's a fantastic option for you. Now I'll jump into a bit of coding, and I'll show you how to do things with K6. I'll show you how we can begin working with it, how does it work, what's the lifetime of a K6 script, how can we simulate a user, verify, do one check, how we can do a test, which is important, and then the meat of the matter, how to simulate a real-world load, how to simulate a user or API that works with your system. So let's get to it. I'll switch. Can you see properly the code at the end? Perfect. So here I have a hello world script. What better way? By the way, K6 was built on Go. Go is the language. But the scripts you create are on JavaScript. Sorry about that. Not my decision. I like them to be on C#, but you cannot have everything, right? So here what we do is we import HTTP module, the sleep, because we want the user not to be like a 555 super quick. And then we do, there is a default function, which is what it will do by default. And I'm doing a request here to this address, which is a test API endpoint that I ask permission to K6. Hey, can I use that for my demos? They tell, yeah, sure, go ahead. They don't know what they are doing because I have a demo later on that will kick there strongly. So how does it look? So before that, yeah, you need to install it. I have it already installed, but I show you how to do it. So you go to k6.io, you go to open source, because this is what I'm focusing today. You go to download, in this case to Windows. And you can use Chocolate or simply install the MSI package, execute it, install it, and next. It's like 1 minute. Once you have that installed, you can execute that in either Visual Studio in a terminal. Let's go there. With K6 and run. Just, it needs to be in lowercase. And you can put the name of the script. Yeah, not the proper folder, and that you don't see too much. So I will switch to command prompt. Yeah, nice. So this is what you see when you execute a script. In this case, a very simple one. But here, you see the local can be local if you execute on your machine, or can be cloud if you use their cloud services. The script you're executing, some data, the iterations. And here on the running, you can see the time it took, the VUs. VUs stands for virtual user that they are simulating, and the iterations that have complete and interrupted. And here you have like a kind of progress bar. That's really helpful. Then you can see the data received, sent, and HTTP request duration. This is the important one. And you have a trend, what they call a trend here. here, you have a statistic that shows the average, minimum, maximum, and the mean. No, sorry, the median. And then a percentage of the 90% and of 95%. And at the bottom, a bit of how much the iterations took. And the iterations. Iterations is the request that the virtual users have issued, right? And here, the virtual users. Nothing more. Pretty simple. Just saying, if any of you have any question, just say it. I'm happy to be interrupted. Then the next question is, how do things happen here? What's the lifetime? I have another example for you. Here, this is simple execution. I'm going to make it small so we can see a bit more. So first is some declarations, some imports. Then you can put some code. This code will be executed as well before anything. And then you have the setup. The setup is what is going to happen at the beginning, where you can do a setup your test data. You can do a login and get the token that all the other executions can use. If you don't want to do the logging as part of the test, of course. Or prepare the data, or download your data, put that in a place that the other test scripts, the default function or the concrete functions will use. And at the end, you have a tear down. That is where you can clean that data to leave everything very clean. Let's see how this runs. Lifetime. You can see here on this part where I put in the logs how things are happening, which makes sense. Just saying that the setup will happen once, the tear down once, but the VO code, it happens according, you have 10 views working, you will print that for a lot of times, right? Then another concept is, how do I put, okay, that's good for one user, for one call, but what if I want 10 users hitting the server for 10 seconds, right? What if I want to check that the time is good? So the calls for this volume of users is under 500 milliseconds or 200, depends on what you need, and that the system is responding properly. So you have these concepts. You have first the options object, which is where you configure everything in K6. In this object, you define what are the views. In this case, you say, okay, I want 3 virtual users. I want this to take 6 seconds. And then on the default function, when you get the result, you can do a check. You have to import it first. And then you can check things like that the status of the HTTP response is 200, everything went okay, or that the duration was under 500 milliseconds. Let's see that one in action. Here you can see the evolution of the progress bar and the views as well. And here you have everything was green. We are happy. We got the duration that now went from a minimum of 100 up to 200. It changed a bit, right? And the views. And 15 iterations, we did 15 requests. We're getting bigger. Another thing is these checks are not a test, pass-fail. For doing a pass-fail test, you need to do a threshold, which you do as well in the options. Let's take a look at that. Here, in the thresholds, I set up a collection of elements. In this case, I'm doing a HTTP request duration, which has a threshold that says 90% must be under 200 milliseconds. And another that all the checks must pass 90%. So I must have all the checks passing more than 90%. And the rest is exactly the same. Yep. Let's do it. This is quite quick, 5 seconds. You can see the progress bar going. You know already how it goes. And now, here, you see that the thresholds are passed. So the test is green. If you put that in Azure DevOps, you would get, yeah, thumbs up. I'm happy. You don't get much more in Azure at the moment here. So what more? Now we have the power to do very simple things, but we want more, right? We want to simulate real-life output. What if, for example, in an office, you have a system that works and gives some kind of service to the office workers, and you know that they come at the office about 8, between 8 and 9, so they are ramping up. Some people maybe early, maybe at 7, but usually it's about 8 that they start coming in. Usually it's a bit smooth because, you know, we have a bottleneck, the doors, the elevators. So what we do is we use stages. Stages, as you may guess, goes again in the options. And I really like it here. You have a collection of elements that determine, okay, that in time, I want 5 users, virtual users in this case. Then I want 3 seconds with 10 users, and then 5, and then 1. So you are determining in a very clear way how your users will scale. Let's take a look at that in action. 5 stages, yes. So you can see here how it's scaling. Oops. Yeah, I stop it. And now it's ramping down. So it's how it works. You put the target, and it ramps down, and then it ramps up. And then this failed. Well, can happen. Now we know how to determine our users. The next thing we do is to be able to control what they are doing. Your users will not simply go to a URL and click F5, F5, F5 to the same URL. You want to determine that, for example, you have Bob, and Bob likes to go to check what's new on the selling page of your company. And you have John, and John will go to see the task that he has to do for the day. He likes to do everything well. And for that, you have scenarios, which, as you can guess, it goes again in options. And changes a bit the rules, the thing. So this is the main thing that changes. So you set up a scenarios, which is a collection of different scenarios, which is an object that have an exec. This is the name of the function of JavaScript that it will invoke. And then it has the executor. The executor is, in this case, ramping views, which is virtual users. They will ramp up and ramp down. And then you have the start time and the start views. You can control everything. And of course, you have stages. So with that, you can do absolutely anything. In this case, I have 2, which one is simple function, and the other is also ramping views that starts 3 seconds later. One will start with 1 virtual user, the other with 2. And one will take 5 seconds, the other will take 2 seconds. And if we run it, you can see now that we are seeing here the 2 running in parallel with the progress bar. That was too quick, maybe. And that's it. Nothing more. That's cool, right? For me, what I like the most is that you can determine what they are doing. If you put the names properly, it's really visual. So that's one of the things that made me choose this technology versus other that can have about double even of performance. But with this, you see the code, and you know what this is doing. Sorry? OK. I really like it. Do you like it? Cool. I'm happy. All right. So there's one commit here. This is text. It's ugly, right? So let's do something about that. I think it's, yeah. So K6 was acquired recently. I think it's about 2 or 3 months ago by Graphana. But this does not have anything to do on the open source project. K6 brings us already some kind of solution for that. It brings a Docker Compose. Yes, you are all familiar with that, probably. File, I think it's, if we go to here, to the GitHub repo, we have a nice Docker Compose that will set up an InfluxDB database and a Graphana container. In fact, I have already installed and set up there, so I will save that part. Yep, so I have that and this. So I have an event database and I have Graphana. Yeah, that enables me to send the output from K6 to this Influx database, and then I have already configured with this dashboard. Graphana, for those that don't know, it's an observability platform that enables us to create dashboards between many other things that I will not go into. So one of these dashboards created by K6 is this one. It's pretty good. And then what I do is, when I connect here, I import and put the link to this one, and I simply load it, and then I can use it. Have it already here. Let me clean that up and put the last 5 minutes. So you can see there's nothing. And the only thing I need to do, I will clean this up so it looks better. I had it on the yeah, this one. So I will run the stages, and I will derive the output to the InfluxDB, which is hosted locally in my Docker. So here we don't see much, but if we go there, and it works. Yeah, it works. Nice. We can zoom it a bit, and we can see a bit the evolution, and also check the checks, and see how it behaves. At the end, it went a bit high, don't know why. So this is a bit sort of okay. So this is how we can have a nice output to put in a PowerPoint or presentation to show your bosses how your system performs. Then, maybe we like to integrate that with our Azure DevOps pipeline, right? So let's get that done. I have a repo here where I created a folder and I put a performance script. This is the template. I will explain in a moment, so I will not dive into it, but this is a K6 script. And then I have a YAML file, which is also in the code. And for this, I have set up here. So I will edit from the proper place. Can you read it properly at the bottom? All right. Cool. This is doing nothing. It's very stupid. But the only thing it's doing is publishing as a test artifact the script. So here I'm checking if the directory performance exists. And if it exists, I will set the variable performance to true. Based on this variable, I check next in a publish build artifact that if you work a bit with Azure DevOps, you should probably know it. And if the variable performance is true, then I publish this path, performance, as perf test as a build artifact. So we can use it later on as it's part of the build. It's a nice way to do it. Then, on the releases, but I'll make you a question first for this WAC. How do I call or how do I execute K6? What are the 2 instructions that go first? Who wants to go and say it?
K6.
Who was that? Yep, perfect. The next one is?
Run.
Perfect. That you come later, get your name, and I put you in contact with K6 people, and they send you a bunch of stuff. All right? So, if I edit this release pipeline, here I have the typical continuous build integration, where it's triggered whenever a release is created, a new build. Here as well, after the release, do this. And here I have a job that has 3 tasks and runs on Linux, in Ubuntu, concretely, not on Windows. And here I have 3 tasks. One of them is installing K6. And all these that you see here, I'm taking that from literally the installation I showed you before, but in this case from Linux. So it's this piece of code, nothing more. Then I do another, which I check if K6 is installed. If this doesn't work, I don't need to do the test. And then I do the test. In this case, I will do a shakedown test. Shakedown is a test with a low amount of data that is meant to check the system stability. So I'm doing it a bit of a kind of an end-to-end test, but a bit harder than really just testing one user or one iteration. And usually what I do is I do that for 2 minutes to 10 minutes. And sometimes it's about 100 users. It depends on the system, right? And I do this before any deployment to staging. So I deploy first to dep state, to the dep environment, and then I can test that there. Some people like to do also on the staging. It can be done. Here, what I have is also K6 run, the name of the script, and then something more. This -e is the way of K6 to give it environment variables, which is the perfect chance to give it some variables that I have defined on the Azure pipeline, like which test do I want to run, which environment I want this test to run on, and your test, if you write it a bit smart, can react on it, so you don't have to write a test for anything, and the same test will do everything. The other test that we could do is load test, which is to test the load that you expect on the system for some time, like half an hour, 1 hour, maybe 1 day, depends. We can do also SOAK testing, or endurance testing, which is testing for a while, for 1 day or 2 days. In healthcare, for example, you have some rules that you have to keep a system working without any delay, any stop for 1 week. So that kind of makes sense. You need to do that in some cases. And then I give it some username and passwords to authenticate, and these are put here in variables. The environment to run is visible. I want to test. I want a smoke test. And the password and username are private. They are encrypted. So they are stored in a secure location in Azure Key Vault in this case. Good. And when we execute that, I'll show you the good one. No, not here. Logs. You see the execution. And this sounds familiar. It is a bit more verbose when you execute it in the cloud. But at the end, you get more or less the same. Here it has a bit more configuration, more things, but you can see the HTTP request duration with some more detail. And this is how you integrate that with Azure DevOps. One more thing, which is cool, is cloud anybody. Yeah. This template I show you is part of Swiss Life open source, where I work. I'm lucky to work there. Here, this open source initiative was created by Philip Verbaum, that was supposed to be here, but he got into Plan B. Hi, Philip. And he's leading, also is my team lead, so I need to speak well. No, he's fantastic. He codes. He's the cheekiest one of all us, so he's amazing. So being in his team is an honor. And he single-handedly created this initiative and is coding like weekends, creating open source. This is a way that we are doing innovation. We are doing innovation in more than one way, but this is one way that we are doing innovation in Swiss Life. And I'm happy to say that 2 of them have recently reached 600,000 downloads. And they are pretty cool. If you work in .NET, you may want to check them. We have Squadron, which was created in a big way by Philip. Also, Marius Matisek was working on it, several, and other colleagues from us. Snapshooper was created by a friend of mine, Norman Scheiber. And yeah, well, I could name all the persons in the team because all of them are doing amazing things. But if you are interested in testing, check Squadron. It's a container management that can do for you a lot of work and simulate a lot of cloud services, mostly Azure. Sorry, but we like Microsoft, we work with Azure. Hey, Brandon, you're happy. Good. So one of them, a very small them, is this one. This is the multi-scenario template. This is a bit of what I was defining to work, a bit like the template that we're using to create our test at Swiss Life. And I make it a bit clean and took a bit the internal parts to make it usable for third parties. And this is already working, showing how to integrate with other services, how to do authentication, how to put a token in the header, and also how to use GraphQL and check that the request is responding properly and check how is your GraphQL behaving. So check it. I think it's interesting. It also shows a bit how to do UI testing. Even that's not the goal of K6, but it's pretty cool. Let me show you a bit it. So I go back here. I have it here, and I've created like two scenarios, concrete scenarios. But let me show it a bit to you. So here I have a lot more things that you haven't seen. I'm handling the arguments with some default arguments that usually will do nothing, and some tests to run, an environment to run, some internal management for. And there I did create some sample and custom metrics, which is also important for counters and for trends. And then the execution type. Execution type is what I just mentioned before. It's the kind of test you want to execute. You can set and use your same test with the same executors to do a load test, to do a soak test, to do a stress test, or in this our case, NDC load and NDC stress test, which we are going to do right now. These are a bit harder than usual. So I wanted to play around with the test services from K6. They kindly let me break them a bit. So that's nice. And here, in this case, I have a backend read scenario that's simply reading information from a REST service. I'm using ramping arrival rate. In this case, this is important because BU, you have a user. And that may be a problem because a user, if you are a user, you request for information, and your system under test is slow. You are still waiting until the information comes back, and you cannot do anything else. That's a user. And when it comes back, you can do another request. But the problem here is that the BU is inherently affected by the performance of the system it has to test. And maybe you don't want that. What I like in this case is to use the arrival rate. Arrival rate says, oh, you have to do 1 request per second. And you will do exactly that. If you need more users, the system will have a pool of users that will reuse the users, and create and destroy them as he needs to do exactly that. And it will ensure that you do a request every second or whenever you want. Is that clear? Perfect. Good. So here I have a start time 0, time unit is 1 second. I will start with 10 iterations per second, and I pre-allocate 650 users. This is getting serious. And I will start 20 seconds with 50 users, then ramping up 120, and then 140. That's a low test. That's not the biggest one. And then I will do another operation, which a lot of users will only consume information, but this will be like 90 or 95%, and some users will also modify information. That's what I'm doing here. This I will upload later in GitHub. It's already on the GitHub that I show you. It's github.com/swisslife-oss/K6 multi-scenario template. So, as I'm lazy, I put that before and I tested everything. So this I'm doing -e, test to run, NDC load. I want it an output to influxDB, so we will see it graphically. And oops, no. I was not in the right directory. That's essentially it. NDC load, yes, now it works. Now you can see the progress. It's initializing here the users. And now it's starting. It's ramping up by iterations. This template, I also put some logging that you can disable or enable. In this case, it's a public service that any user goes, so there is no problem with showing the token. Usually you don't do that, please. You can be fired if you do that. And then here we are going. This test takes about 50 seconds. And now you can see we are reaching more volume than usual. They told me that about 100 requests per second, it starts to break, so I try not to do that. So I was playing until, so the idea is that the load test goes well, but the stress tests usually are used for trying or detecting where are the limits of your system, what's the maximum throughput you can get. And also, usually you detect where the weakest point in your system is. That's a good thing. Well, depends on what you find, right? All right, so it went green and everything is beautiful. So we did here about 3,500 iterations. We did quite a bit of 5. We received about 5 megabytes of data. We sent about 1 megabyte. Well, everything went green. And if we observe it with these, let me trigger it to 5 minutes. You can see that this has another perspective, right? We saw that here we had a drop of performance, or there were less requests, so that's a bit curious. And let's check, so maybe we should take a look into that. And also, when we were ramping up, we had some times that we reached 1 second, and yeah, it is quite good. I got even to 4 seconds sometimes. So that was not that bad. Even the response time over time, it increased, which is not ideal. Maybe we want to scale it or to put more servers if we want to smooth out and enable that we are quite under 200 milliseconds. It depends on what your SLAs are. So now we are going to do the bad guy, the stress test. I'm here pre-allocating almost 3,000 virtual users in the pool. I'm starting with 20 star rate, and I'm reaching up to 340 iterations per second. Back and flow, I don't show it, it's still small. So let's do it. This is stress. Let's see if I can write it properly. What I like about the template is that you have everything in one single script, and it enables a lot of reusability. If it was C#, other things could be applied, but well, with JavaScript, I think it's one of the best ways to do it. Now it's initializing, so this part you have seen, and let me move here. And I will do one thing, so we don't see the other. And I will say that I want from that moment to now. I think it was like that. Doesn't change. Okay, whatever. I'll wait until it's done, so it's 20 seconds to go. No errors at the moment. And we'll see. Oh, we got 1 error. Oops. That was expected. So stress test gives you a shape of how it's. Okay, that was weird. I should not touch it. I think it's done. So let's get here. Last 3 minutes. And if we look at that, we see that we reached 4 seconds and it went higher. So we definitely need to look into what's happening because it can be unacceptable. Second question, what's the event database that I was using on the container with K6 and Graphana? Yep, good, you got it. I have only one more question, so be attentive. So, well, I hope you like the example. I think it defines a bit clearly that sometimes you don't see that in the code. You can see if you look at there, yeah, you definitely see, okay, this request duration took sometimes 28 seconds. That's a clear significative that something went not okay, and you need to look into that. But the data is not as visual as a nice graphic, and it can help a lot, so I recommend you do both. Apart from that, the template is here, and if you are curious, I encourage you to download it, clone it, even to do a pull request if you think of a feature that you can add. Or if you see something is not working, you can also create an issue. With that, the talk is done. As a takeaways, I would tell you to do performance testing unless you want costly surprises. You know, Murphy lives. And you can damage your users, and you don't want that. You can make them lose money. You can then get them to have a bad experience. Stress for you. If there's an issue and the user detects it, guess if it's a weekend and you are there for that, guess what will happen? And probably happened before, right? I've been several weekends working and fixing things that were not tested properly. Who else has been a weekend there working? Yeah, 1, 2, 3, yeah, I feel you. And the second thing is you have to convince whoever is in the lead to do that from the beginning. Put a performance test even your system is not complete. I did that in a further project in a company it was, I won't take the name, they let me do it. And we find a database defect similar to the one we found in the other project, 6 years. It took 1 year and some months to fix, to mitigate. In this case, it took 1 week to fix, of only one person. Think about that. And K6 is good, use K6. I don't get anything from K6. I'm not part of K6, I just use the software and I like it. And try the K6 template. If you like, you are welcome to contribute back. And of course, try Swiss Life open source. If you are into testing, if you are into .NET, you have Squadron, you have SnapShooter, you have a lot of other open source tools that may be of help to you, and they are free. And we are using them in production. So that was it. Thank you very much. It was a pleasure to have so much people here. It's quite amazing. I was not expecting that. Before, I have a last question because I need to give a third kind of swag. Who can tell me what is soak testing? Load testing? No? Okay. What is the company that I use to show the graphical view?
Graphana.
Perfect. You got it. So that was it. Thank you, everybody. It was amazing to be here with you. So, you have any questions?
What exactly is a virtual user? Is that like a thread?
Yeah, it's like a virtual, separate, and isolated process that acts as a user doing whatever you want to do in that either default function or the function that you name.
Okay.
Yeah. Does it respond to your question? Perfect. I don't know if... More questions? Everything was clear? So, I'll be looking at the Slack if anybody has another question. So, thank you very much.